Hello friends, welcome back. Hearty welcome to you. In this session we will look into some examples related to finding out the equation of a straight line when we know the slope of the line and also y-intercept. So let's look into these examples by leveraging the formula y equal to mx plus c. So let's look at the first example. Find the equation of a straight line with slope minus 1 by 3 and y-intercept minus 4. Now what is the equation of the straight line when we know the slope of the line and also y-intercept? This is slope of the line and c is the y-intercept. So when we know both of them, one way to frame the equation of the line is very simple, is y equal to mx plus c, where m is slope and c is nothing but the y-intercept. We will be leveraging this formula. So let's look at the first problem. Find the equation of the straight line with slope equal to minus 1 by 3. So m equal to minus 1 by 3 and y-intercept equal to minus 4. What is y-intercept? C. C equal to minus 4. So I have to find out the equation. The equation is y equal to minus 1 by 3 into x minus 4. Substituting in the formula y equal to mx plus c. Now you simplify this, multiply by 3, you will have 3y equal to minus x minus 4, nothing but equal to x plus. So if you multiply by 3, you will have 3y equal to minus x minus 4 into 3, that's nothing but equal to x plus 3y plus 12 equal to 0. So it's a direct substitution. Let's look at the next one. Find the equation of the bisectors of the angles between the coordinate axes. Find the equation of the bisectors of the angle between the coordinate axes. Now let's try to draw how the coordinate axis looks like. So suppose I say this is my x-axis and this is y-axis. You are looking at positive side here, and this is negative y, and this is x negative and y negative. Okay, this is your origin. Now find the equation of the bisectors of the angles between the coordinate axis. Now let us take this coordinate axis. Now what is the angle between them? The angle between them is right angle. We know that it's nothing but equal to 90 degrees. Now bisector of the angle between the coordinate axis means we are looking at the line which makes angle of 45 degrees. So that takes care of first quadrant and the third quadrant. But you can also have another line which bisects second and fourth quadrants, right? In the second quadrant it will take care of second and fourth quadrant. So you will have actually two lines, with one a positive slope and another one with negative slope. Now how to find out the equation of these lines? Let me repeat again. We want bisectors of angle between coordinate axes. So every coordinate axis you take, draw the angular bisectors. The bisector is 90 degrees, 45 degrees, extend it again. Here also 45 degrees, total is 90 degrees, so from 45 degrees from x-axis. Now we want to find out the equation of these lines. Let us say this line we want to find out the equation. So this is L1 and let us say this is equal to L2. Now we know that both of these lines pass through origin. That means they pass through 0, 0. So in y equal to mx plus c, c equal to 0, because your y-intercept is 0. So this equation becomes y equal to mx. Now only we have to find out the slope, then we are done with the equations. Now what is the slope? Let's look at the first one. If you look at L1, the angle is 45 degrees. The inclination is 45 degrees. If you look at L2, the angle is 90 plus 45. Or can I say that it's nothing but equal to, you can look at that angle is nothing but equal to 135 degrees. So we have two lines, one line making an angle 45 degrees, another line making an angle 135 degrees with the positive direction of x-axis. That means the slopes will be L1 slope, L1 slope is nothing but equal to tan of 45, that's equal to 1. L2 slope is nothing but equal to tan of 135, that's equal to minus 1. So if you substitute that, the equations will be y equal to 1 into x is x, or y equal to minus 1 into x, that's nothing but equal to minus x, which we can say that that's nothing but equal to x minus y equal to 0, or x plus y equal to 0. So we can have two equations which we can say x plus or minus y equal to 0. So you can see that in the first quadrant and the third quadrant, if x is positive, y is also positive. In the second and fourth quadrant, you can see that if x is positive, y is negative. If x is negative, y is positive. So that's how we can find out the equation of bisectors of the angle between coordinate axes. The angle between any coordinate axis, if you take any quadrant, it's 90 degrees. So the angular bisector makes an angle of 45 degrees with the positive direction of x-axis, and also another line makes 135 degrees with the positive direction of x-axis. These two are the angular bisectors. Let's look at the next problem. Next one. Find the equation of a line that has y-intercept minus 4. So C equal to minus 4 and is parallel to the line joining 2 comma minus 5 and 1 comma 2. Now to frame the equation, in the equation y equal to mx plus c, we need m and c. We know the c, we have to find out m. But we know that there is another line which is parallel to this line. So you know that parallel lines have same slope. So the slope of this line, whatever we are trying to find out, will also be equal to the slope of the line joining 2 comma minus 5 and 1 comma 2. Now what's the formula for m? Slope equal to y2 minus y1. So if I take this as x1 y1 x2 y2, y2 minus y1, that is 2 minus of minus 5 divided by x2 minus x1, that is 1 minus 2. That's nothing but equal to 7 by minus 1, that's equal to minus 7. So we have slope, we know c, so we can directly go ahead and say y equal to minus 7x minus 4, or nothing but 7x plus y plus 4 equal to 0. So instead of directly giving the slope, sometimes we can be given that the slope of the line is parallel to another line joining some point. So you have to find out the slope and equate it because they are parallel lines. Okay, let's go to the next one. Similarly, find the equation of a line which is perpendicular to the line joining this and cuts off an intercept of length 3 on y-axis. So we know c equal to 3 because it says intercept of length 3 on y-axis. Equation of line which is perpendicular to the line joining. So perpendicular to the line joining 4 comma 2, 3 comma 5. So if I find out the slope of this line, then the reciprocal of that multiplied by minus 1 is nothing but the slope of the line what we are looking at. Now what is the slope of this line joining 4 comma 2, 3 comma 5? That will be nothing but equal to m dash equal to 5 minus 2 divided by 5 minus 2 y2 minus y1 by x2 minus x1. That's nothing but 3 minus 4. So that is nothing but equal to minus 3 because 5 minus 2 is 3, 3 minus 4 is minus 1, so it is minus 3. So m is nothing but equal to 1 by 3. If m dash is minus 3, we know that two lines are perpendicular, then their product of the slopes should be negative 1. So if it is minus 3, the other one should be reciprocal and multiplied by minus 1. So that's nothing but equal to 1 by 3. Now we have m and c. we can easily go ahead with the equation y equal to mx plus c. So y equal to 1 by 3 into x plus 3. This is nothing but equal to 3y equal to x plus 9 or x minus 3y plus 9 equal to 0. So that's how we can do. So we have seen two examples. In one, the slope is obtained by finding out the slope of another line which is parallel, and in this example we obtain the slope of the line by finding out the slope of the line which is perpendicular to this line. Now once I know that slope, I will reciprocal it, I will reverse it, and I will multiply with minus 1, so that the product of these two slopes is equal to minus 1. If you remember, m1 m2 equal to minus 1 if m1 m2 are slopes of two lines which are perpendicular to each other. So let's look at the next problem. Find the equation of the straight line intersecting y-axis at a distance of 2 units above the origin. So can I go ahead and say c equal to 2, because 2 units above the origin, that means its intercept is positive 2. Okay, and making an angle of 30 degrees with the positive direction of x-axis, that's nothing but theta equal to 30 degrees. Now for the equation y equal to mx plus c, I need c and m. C is already available. M I know is nothing but equal to tan theta, that's nothing but equal to tan of 30, that's nothing but equal to 1 by root 3. So if you substitute y equal to 1 by root 3 into x plus 2, or root 3y equal to x plus 2 root 3, or x minus root 3y plus 2 root 3 equal to 0. So that is the equation of the straight line intersecting y-axis at a distance of 2 units above the origin, so positive intercept, that's why c is 2, and making an angle of 30 degrees with the positive direction of x-axis. So that's how some of the examples we can look into. Now just before wrapping up, let's see how we got the equation y equal to mx plus c very briefly. Now let's see very briefly how we got the equation y equal to mx plus c, since we have done so many examples on that. Actually if you can refer to the coordinate geometry playlist, it's already available I think, but anyway let me just take a couple of minutes to quickly summarize on that. So y equal to mx plus c. So there is a straight line which is making an positive intercept of c. So if it is positive intercept, let us say that's a line we are talking about this line. The line slope is m and this intercept is nothing but c. So what will be the coordinate of this point? The point coordinates will be 0, c. So we know the slope is nothing but equal to m. So let us take some arbitrary point x, y on the straight line. Now we know slope is nothing but equal to delta y by delta x, that's nothing but y minus c by x minus 0. Because the slope is same wherever you go on the line. You take 2 points, one point we know is c is the intercept, so 0, c is one point, and another is arbitrary point x, y. Now if you simplify this, y minus c equal to mx, or y equal to mx plus c. So this equation is very useful whenever you know the y-intercept. Whenever you know the y-intercept, that's nothing but c, and you know the slope of the line, very easy, you can substitute in y equal to mx plus c. So in the next session we will look into another type of equation of straight line like point slope form. We will look into some examples on that. Okay, see you in the next session. Thanks for visiting. Bye for now.